Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Physics Paper 1 Higher Tier from 2025. Question number 9 is on the topic of energy. Figure 11 shows a garden water feature. So you have a top container and a bottom container. The height difference is 70 centimeters. The water feature has an electric motor that pumps water from the bottom container to the top container. The pump transfers 0.343 joules of gravitational potential energy to the water each second. Gravitational field strength equals 9.8 Newton per kilogram. Determine the mass of the water passing through each pump. Use the physics equation sheet. For that, I would use GP equals mgh for potential energy. Let me write the proper symbol rather than GP. That's potential energy equals the mass multiplied by the gravitational field strength multiplied by the height. We need to find the height. We need to find the mass. Height we already know. Height is 70 centimeters, which is 70 divided by 100 will give me 0.7 meters. That should give me a mark. So 0.0 0.343 equals the mass is what you're trying to find multiplied by 9.8 multiplied by 0.7. So mass equals 0.343 divided by 9.8 multiplied by 0.7. That gives me 0.050. 0.050 kilograms or 50 grams. The power of the pump is 4.86 watts. The resistance of the pump is 6 ohms. Calculate the charge flow through the motor in 30 minutes. The time has to be converted into seconds by multiplying that by 60. Each minute has 60 seconds, so that would give me 1800 seconds. So that should give me a mark out of the 6. Right, so I can find the current before I find the charge, which is Q. I use P equals I squared R. I can find the current using this equation, and then I can use the equation for charge and current. Right? Q equals I T. This is the second equation to find the charge. So let's use this. 4.86 equals I squared times 6. So I squared equals 4.86 divided by 6. And I equals to the square root of the answer. Before I find the answer, let me just write it as 4.86 divided by 6. That would give me a current of 0.90 amps. Right. And then I can use it in this equation. Q equals IT 0.90 multiplied by 1800. That would give me 1620 coulombs of charge. So 1620. The pump motor breaks and is replaced with a new motor. The new motor has the same power input but has a greater efficiency. Explain how the new pump motor would affect the flow of water in the future. If it has a greater efficiency, that means more energy is being converted to useful energy. That means it's working better. More water actually flows through. Means a greater mass of water flows through each second, because it would actually have a higher power. Right? Now, because they're asking us to explain, since a greater proportion of the energy supplied is useful power output. Or you could say a smaller proportion or percentage of energy is wasted as well, which is the reverse. That brings us to the end of question number 9. I will see you in question number 10.